Hello my dear students, welcome to my physics class. Our today's topics are electromagnetic induction, generator and transformer. Let's start now. Electromagnetic induction. Electromagnetic induction is the production of an electromotive force or voltage across an electrical conductor in a changing magnetic field. That means if magnetic field is changed inside a coil, then an electromotive force or current is produced through the coil. Electromagnetic induction was discovered independently by Michael Faraday in 1831 and James Clerk Maxwell mathematically described it as Faraday's law of induction. Lenz's law described the direction of the induced field. That means from the Lenz's law we can determine the direction of this current. This voltage is called induced voltage and this current is called induced current. Look at the picture. Here another picture. When a bar magnet is inserted into a coil or pulled it out, a sudden current is produced through the coil. In the first picture, if a bar magnet is inserted into the coil or if this bar magnet pulled out from this coil, in both cases a current is produced through this coil. And this current is determined by the galvanometer connected to this coil. That means a current is produced when the bar magnet is inserted into this coil or the bar magnet is pulled out from this coil. But in these two cases the current flow will be opposite direction. That is, when the bar magnet is inserted into this coil, the current will flow in a certain direction, and when this bar magnet is pulled out from this coil, then the current flow will be in the opposite direction. From the second figure, we can understand what is the main cause of production of this induced current. When the bar magnet is brought near to this coil, then the magnetic flux or magnetic field through this coil is changed. Here the bar magnet is brought near to this coil, then magnetic flux inside this coil is increased, but when the bar magnet is taking out from this coil, then the magnetic flux is decreased. Therefore an induced voltage or induced current is produced through this coil, and this induced voltage or induced current is determined by the galvanometer connected with this coil. That means the main cause of production of induced current or induced voltage is the changing of magnetic field through the coil. We can change the magnetic field by bringing the bar magnet near to this coil or by taking out this bar magnet from the coil. Here another figure. In this figure, here is a coil and this coil is connected with the battery. When the switch is on, current flows through this coil, and we know when current flows through a coil, a magnetic field is produced around the coil. That means this coil now acts as a bar magnet. When the switch is on, it will act as a magnet. Therefore the magnetic field through this coil will be changed. Therefore an induced electromotive force will be produced through this coil. Here this coil is known as primary coil and this coil is known as secondary coil. EMF or current produced in first coil by current flowing through the second coil near it. In the second figure, here the current carrying coil is moving towards the coil and away from the coil. Therefore, an induced electromotive force is producing through this coil. From this discussion, we can say if a magnetic field or magnetic flux is changed through the coil, the electromotive force or induced current will be produced. We can sense this magnetic field or magnetic flux by many ways. We can sense the magnetic field by bringing a bar magnet near to the coil, by taking out the bar magnet from the coil, or by current flowing through another coil near to this coil, or by moving a current carrying coil near to this coil. In these different ways we can sense the magnetic field and we can produce induced current or induced voltage. That means the main cause of production of induced voltage or induced current is changing of magnetic field inside the coil. Generator. Here a bar magnet is rotating near to this coil. Therefore, the magnetic flux through this coil or the magnetic field through this coil is changing continuously. Therefore, a continuous flow of current is obtained from this coil. Here the magnetic bar is rotating. Therefore, the magnetic flux through this coil is decreasing and increasing. Therefore, current flow through this coil is in a certain direction and again in opposite direction. That is, here the alternating current is producing through this coil. Continuous flow of current can be obtained by the continuous relative motion between magnet and current. That means if we maintain a relative motion between magnet and current, magnet and coil, then induced current or induced voltage is produced through the coil. Using this principle, we can prepare a generator. We know in case of DC motor, if the current flows through the coil, then the coil is rotated inside the permanent magnet. And if we reverse this process, that means now here the coil is connected with the battery, but we will connect this coil with galvanometer or ammeter and we will rotate this coil. If we rotate this coil, then the current will be produced through this coil. That means when current flows through this coil and the coil is inside the magnetic field, then the coil will be rotated. But if we rotate the coil, then the current will be produced through the coil. That means DC motor or motor and generator are reverse process. Here a coil is rotating inside this magnetic field. Therefore, an induced electromotive force or induced current is producing here. Here also the coil is rotating inside the magnetic field and induced current is producing through this coil. When the coil is rotated inside a magnetic field, then the magnetic flux through this coil is changing continuously. As the magnetic flux or magnetic field is changing continuously, therefore a continuous flow of current is obtained from this coil. This is the main principle of generator, producing current by generator. Transformer, it's a transformer and it's the internal construction of a transformer. It's an iron core, here coil, here is also coil. This coil is known as primary coil. Here the AC supply is connected with this coil, that means it is input, and input coil is known as primary coil, and here we will get the output, and this coil is known as secondary winding or secondary coil. Here output terminal and here input terminal. AC power supply is connected with the primary coil and we will get the output from the secondary coil. We know if the current flows through a coil, then it will act as a magnet. Here AC current is flowing. We know AC current means alternating current. When alternating current is flowing through this coil, therefore due to this alternating current, a alternating magnetic field will be produced. When the current flow will be increased, magnetic field will be increased. When current flow is decreased, magnetic field will be decreased. In case of AC current, the magnitude of the current flow is not constant. The magnitude of the current flow is changed. The current flow is increased, the current flow is decreased. Therefore the magnetic field produced around this coil will be changed. Due to this changed magnetic field, the magnetic flux through this coil will be changed. Therefore an induced electromotive force or induced current is produced through this coil. That means we can change the magnetic field by alternating current or AC current, and when the magnetic field is changed by AC current, the magnetic flux through this coil will be changed continuously, and an induced electromotive force or induced current is produced through this secondary coil. This is the main mechanism of transformer. Here the input voltage is applied here, and this coil is known as primary coil and this coil is known as secondary coil. Consider the number of turns in the primary coil is Np. Here number of turns is Np, and here secondary coil, that is output terminal, number of turns in the secondary coil is Ns, S for secondary and P for primary. Voltage applied in the primary coil is Vp. Here Vp voltage is applied here, and voltage obtained in the secondary coil, it is output voltage is Vs. Then we can write Vs by Vp is equal to Ns by Np, or Vs is equal to Ns divided by Np into Vp. Voltage obtained from the secondary coil can be calculated using this formula. The current flows through the primary coil is Ip. Through this coil current flow is Ip, and current flow through the secondary coil is Is. Then we can write Is divided by Ip is equal to Np divided by Ns is equal to Vp divided by Vs, and from this equation we can write Is is equal to Np by Ns into Ip, and Is is equal to Vp divided by Vs into Ip. From these two equations we can calculate the current flow through the secondary coil. If the number of turns in the primary coil and secondary coil are different, then the voltage in the primary coil and secondary coil will be different. We can change the voltage in the primary coil and secondary coil. We can increase the voltage or we can decrease the voltage by changing the number of turn in the primary coil or in the secondary coil, but power will remain same. We know power P is equal to VI. Here we can change the voltage or current, but power is always same. We cannot change the power, we cannot increase the power, or we cannot decrease the power. Here we can change the voltage by increasing or decreasing by the number of turns in the primary coil or secondary coil. There are two types of transformer, one step up transformer and two step down transformer. Here step up transformer, in this case the number of turns in the primary coil is less than the number of turns in the secondary coil. Here the number of turns is more than the number of turns in the primary coil, therefore we will get the more voltage from the secondary coil than the voltage in the primary coil. In step up transformer we can increase the voltage, therefore it is known as step up transformer. Suppose number of turns in the secondary coil is 10 times that of number of turns in the primary coil, then we can increase the voltage 10 times. That means if the voltage in the primary coil is 10 volt, the voltage in the secondary coil will be 100 volt. That is, we can increase the voltage by this step up transformer. And step down transformer, here the number of turns in the primary coil is more than that of the number of turns in the secondary coil, therefore the output voltage will be less than the input voltage, and this type of transformer is known as step down transformer. Transformers are used in transmission system when the power is supplied from the power station. Here power generating station, when power is transmitted from the power station, then the electric power is transmitted at a high voltage, and to convert this voltage to a high voltage, a step up transformer is used. We know more the current flow through the conductor, more will be heat produced. Therefore in the transmission system the power is transmitted at a high voltage and at a low current. To make the high voltage, a step up transformer is used, and we know for our household purposes we need 220 volt only. To make high voltage to a low voltage, a step down transformer is used. That is, from the power station, here step up transformer is used to make the high voltage, and for consumer level use the voltage is converted at a low voltage by using a step down transformer. And it's a mobile phone charger. Here we can charge our mobile phone by using this charger. Here it is a DC voltage or DC current device. We know the voltage of a mobile phone is generally 3 volt to 5 volt, but in our power supply the voltage is 220 volt. Here 220 volt and we need only 5 volt. To make this low voltage we need a transformer, and here the internal construction. of a mobile phone charger. Here a transformer is used to make the 220 volt to only 5 volt. That is, it is step down transformer. And here transformer, using this transformer we can make from high voltage to low voltage. That is, step down transformer is used in mobile phone charger. Mathematical problem. The number of turns in the primary coil of a transformer is 2000 and the number of turns in the secondary coil is 50. If 220 volt is applied in the primary coil, what is the voltage in the secondary coil? That is, number of turns in the primary coil is 2000 and number of turns in the secondary coil is 50. And voltage applied in the primary coil is 220 volt. What is the voltage in the secondary coil? Solution. Here number of turns in the primary coil is 2000 and number of turns in the secondary coil is 50, and voltage applied in the primary coil, that is Vp, is 220 volt, and Vs is equal to what? And we know Vs is equal to Ns by Np into Vp. Here Vs is equal to Ns, that means Ns is 50, and Np means 2000, 50 divided by 2000 into Vp means 220 volt. And after calculation, this is 5.5 volt. That is, voltage obtained in the secondary coil is 5.5 volt. Homework. The number of turns in the primary coil is 500 and number of turns in the secondary coil is 50. If the current flow through the primary coil is 0.25 ampere, what is the current flow through the secondary coil? My dear students, please try to solve this problem.